All right, guys, so we're back from the Zoom disturbance as usual. So as I was saying, I'm just going to walk you through the calculation for the table so that when you're constructing your table, you'll understand what to do when you're calculating for a quadratic equation. All right, so as you notice here, our first row will take the range of values from -6 to +4. And so this is what they give you as a range for x. So you're taking x values between x equal -6 up to x equal +4. So it means that you would have to include -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. All right, so that's how we put in our values for the x or the x's. Now, our next row will take the first term from the equation. So here we would have the 3x squared term. Now, what it means for this row, whatever your x value is, you're going to square it and then times it by 3. All right. It would be good if you have your calculator close by so that we can verify these answers. All right. So if you have your calculator, you can just check as we do these calculations. All right. So that would be for the second row. All right. Now for your third row, we're going to put in the positive 10x in this row. So for this row, whatever your x value is, you're going to multiply it by 10. All right. And then for the next row, which is the fourth row, we're just subtracting 8 all the way through. And then our last row is what we get after we do our calculation for the rows between the x and y row. So once we add those columns between the x and y rows, then we will get our y values. All right, guys. So let us go ahead and work through the calculation. So we're doing the first row, which is 3x squared. So whatever the x value is, we're going to square it first, then we multiply it by 3. So x value equal -6, then we have 6 squared, -6 squared. You will get -6 times -6, so that will give you a +36. And so you multiply 3 times 36 and you should get 108. Can anybody verify that? Can you check and ensure that these calculations are correct? All right, so for x equal -5, you will square -5. When you square a negative, you get a positive. So you'll get 5, 5, 25, positive 25 times 3, you'll get 75, positive 75. Now for x equal -4, when you square that, you will get 16. So -4 times -4, positive 16. And you multiply that by 3, 16 times 3 will give you 48. -3 squared will give you +9. And so -3 squared give you +9, and then you multiply by 3. So 3 nines give you what? I think this should be 27, shouldn't it be? I think this should be 27, guys, right here. So this should be 27 here. All right, so it means that we have to fix that calculation. Now the next one, when x is equal to -2, -2 squared give you 4. 3 4 is 12. -1 squared give you 1, 3 ones 3, 0 squared give you 0 times 3, 0 times 3 give you 0, 1 squared give you 1 times 3 give you 3, 2 squared give you 4, and 3 times 4 give you 12, 3 squared give you 9, and 3 times 9 give you 27. And 4 squared give you 16, and 3 times 16 give you 48. Now, what you should notice that for this row, the values kind of mirror themselves from the 0 position. So if you go to the right of 0, you will have 3, and then to the left of 0, you have the same 3. To the right of 3, you get 12. To the left of the 3 on this left-hand side, you will get the same 12. So you see that you have kind of a mirror image of the values to the left and right of 0. Everybody see that? Raise your hand if you see that for me, please, if you understand what I'm saying. So here we have 0. If you look at the value to the right of 0, you have 3. To the left of 0, you have 3. To the right, you have 12. And to the left, you also have 12. So if you follow that pattern, you'll see that the values are mirroring themselves. All right, so that's what I'm trying to point out to you guys. So it means that in your calculation, what you get to the left, you should be getting it to the right. So if you're not getting the same values to the right when you're squaring them and multiplying them, then maybe you're doing something wrong. All right, guys? All right, so next we want to calculate the row now with plus 10x. So in a similar way, all you're doing, you're looking for your x values and you're multiplying it by 10. So x equal to -6. -6 times 10 give you -60. X equal -5 times 10 give you -50. X equal -4 times 10 give you -40. X equal -3 times 10 give you -30. X equal -2 times 10 give you 20. X equal -1 times 10 give you 10. And x equal 0 times 10 give you 0. And when x is equal to +1, you get +10. X equal +2 times 10, you get +20. X equal 3, and you multiply by 10, you get +30. X equal +4 times 10, you get +40. Now the next row, we're just simply subtracting 8 in all the columns right across for that row. Now that we have filled in all our values, our next step now is simply to do the calculation of our columns. And all we're doing, we're adding the columns between the X row and the Y row. All right, so for this first column, we're adding 108 plus -60 plus -8. So once you add these, whatever we get, we put as our Y value. So if you add -60 with -8, you get -68. And if you have 108 minus 68, you will get 40. Now the next one, you'll have +75, but you're subtracting -50 and you're subtracting -8. You add the two negatives, you get -58. You subtract that from 75, you should get 17. So guys, just verify these calculations for me as we move along. It's important that you verify them so that we have it accurate. Yes, Ms. Wesa.
Sir, how you got the 108?
Oh, the 108 is when we square 6. -6, we square it, we get 36, and we times it by 3. what we get.
Okay, sir.
Okay. All right, so that's how we get all of this row now. Whatever the X value is, we square them and then times them by 3. All right, Ms. Waysom?
Yes, sir.
All right, so for the next column, we're adding positive 48, and then we have negative 40, negative 8. So we get negative 48, positive 48. We know we're going to get 0 there. Next, we would have 27, and we have negative 38. And if we check and see if this turn out to be 11 for me. So we would now have 38 minus 27. So it would be negative 11. All right, so I guess the 27, this 37 was an error. All right, any question, guys? You're following so far? And we do the same thing for the next column. So we have positive 12, negative 20, negative 8. We add the negatives together, we get negative 28. And then we have positive 12. Now we have to take away 12 from 28 and keep the sign of a negative. So 12 from 28, in this case, we will get 16. And so it will be negative 16. And for the next column, we have positive 3, but we have negative 18. So that will give you a negative 15. Are you verifying the answers that we're getting for y, guys? The next column, we have x equals 0. Then we have 0 plus negative 8. So 0 minus negative 8, we get negative 8. Then the next column, we would have 3. And then we have positive 10, give you positive 13 minus 8, we get 5. Next column, we have positive 12 with positive 20, that will be 32, minus 8, we get 24. Then we have positive 27 for the next column plus positive 30, that will give you 57, minus 8, we get 49. And then for the last column, we have positive 48 plus positive 40, that gives us 88, minus 8 will give us 80. All right, everybody verify that. Is the calculation okay? All right, thanks much, Ms. Cabrera. Ms. Cabrera, you verified it?
So why you put the negative sign in front of the middle numbers?
Oh, you mean here?
Yes, sir.
Hold on a sec.
No, I mean the bottom of the y-axis.
These are talking. No, these are just underlined, so these are not negative. These are not what you're talking though.
No, I was talking the y-axis, like the middle part where you start adding the negative signs.
All right. You're saying here, down here?
Yes, sir.
Okay, so it's based on our calculation. So for this column, we are adding these values. All right, so you notice that this is a negative value and this is another negative value. So you have to add these negative values together. So you get negative 38, but now you have a positive 27 up here. So you know that you have to add these two together to 27 plus 38. So remember, when you're adding a positive and a negative, you remember the add and when we say what you owe, what you have and what you owe is the same principle. So if you have $27 and you owe 38, you pay back the $27, but you still owe how much? So in other words, if you take away 7 from 8, you get 1. You take away 2 from 3, you get 1. So you still owe 11. So that's why this becomes negative down here. You follow?
No, sir. Yeah.
Right, so it's the same thing for the rest of columns that have negative. All right, good. So any other question? Any other question? Can we move on from here? All right, if there's no question, I'm going to clear what we have here and move to the next slide. All right, so the next step now is for us to be able to plot this graph. So moving to the next slide. All right, so here we have our graph paper. Now, I would like for you to actually, even though I'm doing this graph, I would like you to do this graph with me. So in other words, you should have your graph paper and you should be using whatever I'm doing, you should be using the same scale and so on. And you should be plotting the graph as we go along. So let me see the hands of those who have everything ready for that. Raise your hand. All right. So I still see some persons who are not prepared for this class, guys. I mean, you have to try to maximize the use of your time. You have to come prepared with your tools to do the work. All right. You have been told from previous classes that you need to have your graph paper and you need to go through this process. If you don't go through the process, you don't get the practice. You don't get the practice, you don't develop the skills quickly. All right, so that's your responsibility there. So you have to ensure that. Now, I want you now to help me to determine, first we want to find a position where we want to put the y-axis. So we always try to put in the y-axis first so that we can get a sense based on the x values. We know that at the 0 position, the y-axis is going to fall at the 0 position. So to the left of the y-axis, you want how many units to the left. So it is based on how many negative you have here. So you have from -1 to -6. So it means that you really need 6 spaces to the left of the y-axis. Now, to the right, you would have your positive values. So you only have 1, 2, 3, 4. So you need 4 spaces to the right of your x-axis. So the question now, do we have enough space with these boxes, with these centimeter boxes? Do we have enough spaces to get 6 to the left and 4 to the right? Now, if it is that we don't have enough boxes, that means we will have to use a scale that can accommodate all the values. All right, so anybody have any suggestion?
You can make one box.
All right, Ms. Caveira first, then Ms. Wilson. Go ahead, Ms. Caveira.
So you can make 1 box equals 2.
All right. Is the same suggestion you have in mind, Ms. Wilson?
Yes, sir.
All right, so yes, that would be correct. Now, so if we're going to make one of these centimeter box equal to 2, how many of them we're going to need so that we can go over 6 spaces to the left? Anybody? How many of the boxes we're going to need?
Sir,
3.
5 of the big box
3,
from 0.
All right.
Well, from my graph sheet.
All right. So if we're using one of these boxes for 2 and we're going over 6 places to the left, that means we need to have at least 3 boxes to the left. So, but if we if we look at the right, we only need how many boxes? To the right of 0, how many positive numbers we have?
4, sir.
So we only need 2 boxes to the right of the y-axis. So it means then we can just put our y-axis in a reasonable place where we can get 6 to the left and 4 to the right. So if we position our y-axis in the middle, we should be able to put in these values. All right, so we position our y-axis here. All right, so we should be able to now have the 3 boxes to the left and 2 boxes to the right. All right, what about now our x-axis? Now we want to position our x-axis so that we are now looking at the y values. So we want to go up with a y value up to positive 80, and we want to go down with a y value down to negative 11, no, negative 16. So you look for the largest negative value to tell you how far down below the x-axis to go. And you look for the largest positive value to tell you how far above the x-axis. So in this case, we want to go 80 above the x-axis, and we want to go 16 below the x-axis. Now, what scale do you propose that we could use to accommodate 80 above and 16 below? So if we're using the centimeter boxes, what would you use?
1 centimeter representing 10 units, sir.
Yeah, so that would work very well. All right, so if that is the case, that means we would need only 10 boxes above the x-axis. So, well, we really don't need 10, we only need 8 above. So if we can just do a rough check. So from above, we have 1, 2, 3, 4, 5, 6, 7, 8. So it means that, and we have 2 boxes below, which would go down to negative 20, which would accommodate what we have in terms of negative 16. So if we put our x-axis right here, then that should be able to accommodate our y values. Agree, guys? All right, so let us see now if we are able to put in these values. So if we're going on the y-axis, we're going by 10. So we say 10. 20. 30. 40. 50. 60. 70. Well, way up the top here would have 80. All right, so there we go. So our y would be up there, positive y. So we'll have 0 here, and we are going down negative 10. And then now our last value down here would be negative 20. All right, so now to the right, we are counting by 2. So 2. Four. And then we have 6. We don't need to go any further than that. All right, now, in the interest of time, guys, I'm going to allow you to write the scale on your paper yourself. So we're going to have negative 1 here, negative 2, sorry, negative 2 rather. So I have negative 2, negative 4, and then we have negative 6. All right, so we don't need to go any further there. All right, so so over here we have our negative x values. Now you can write in your scale. We're just going to do the plotting here now. So if x is equal to negative 6, then we want to go up to positive 40. So negative 6 on the x going up to 40 would put us right here. So that would be our position. All right, so the next point we would have negative 5 with positive 17. So between negative 4 and 6 would be positive 5, right between the middle box, and we are going up to positive 17. Now 17, remember each of these tiny boxes now going to be equal to 2 on the y-axis. So if we're at 10, then we're going to have 12, 14, 16, then 17 going to be somewhere right here in between. So we're going all the way to 5. Going all the way to 5, and 5 is in the middle here. And we should be somewhere here, right about here in the middle. All right. Now, the next one we want is negative 4, x equal negative 4 and y equal to 0. So x equal to negative 4 and y equal to 0. So that would be right on the x-axis. So negative 4 and 0 would be right here, right on the x-axis. So right here, it will cut it right, oops, sorry. Right here, all right. The next one would give you negative 3 and y equal negative 11. So negative 11 would be 1 unit below 10, or between one of the tiny boxes below 10. So we're going with negative 3, which is in between 2 and 4, negative 2 and 4. And so we should be right around here. All right, so the next one would be x equal to negative 4 and no, we have that already. Negative 2 and negative 16. So x equal negative 2 with negative 16. So we are counting down 3 tiny boxes from 10 to get 16. So we would be right around here. We'll go right across to 2, which is right here. And then now we have x equal to negative 1 with negative 15. Now 15 would be one little unit above 16, which is around here. So it should be right in the middle here. And then now, x equals 0 with -8. So when x equals 0, you're coming down -8, so you count 4 units from 0 coming down, 4 tiny boxes, so you'll be right here. And then when x equal to 1, y is equal to +5. So 1 is right here, +5 is somewhere right between 10 here. And when x equal to 2, y would be 24. X equal 2, y would be 24, which would be right here. And when x equal to 3, y is 49, so 3 is right in the middle between 4 and 2. Then you're going all the way up to 49, which is close to 50, which is about here. And then now when x equal to 4, y is equal to 80. X equal 4, y is equal to 80, which is all the way up, on top here. All right. So all we have to do now is to draw our curve. And so we want to draw a smooth curve. So what we do is to try not to lift your hand when you're drawing a smooth curve. Don't lift the pencil off the graph paper, and don't do any jagged curve. So you're going to draw one smooth curve. Try to connect all the dots. Try to keep your hand steady enough. Take a little time until you get all the points together. It won't be perfect, but you should get a fairly accurate graph looking like that. Now, with practice, you should be very good at drawing these curves. All right, guys, any question? Let me see the hands of those who are actually drawing the curve on the graph paper. Okay. All right, anybody finish drawing their curve? And if you'd like, you can send it to the WhatsApp, to my WhatsApp number, my personal number. All right, guys. All right, is everybody good with this now? Can I clear what we have here? Or is some person still drawing? So is some you want to say something?
No, sir.
Okay. Is everybody finished drawing the graph? Raise your hand if you're still working on the graph for me, please. All right, so if you are finished, I'm going to clear what we have here and move on to the next page, slide. All right, guys. So now you have to take the time out to practice so that you can draw these curves accurately. All right, now this is another diagram for the same curve, but this graph is not on the same graph paper, so but it's still pretty much representing a similar curve. All right. And what you notice with our parabola, you have it looking like a valley. And that is because the number in front, the x squared, is a positive, so you will always get a curve shaping like this. All right. Now, here we're going to look at what we call the axis of symmetry based on the parabola. Now, what we have here is our quadratic equation in the general form. So in the general form, you have y equal to ax squared plus bx plus c. Now, what do we know about quadratic equations? Is that they will always give you a parabola, either looking like a mountain or one that is looking like a valley. Now, because this is the property of the curve, there are certain things that we can learn about the curve. And one of the things that we're going to be looking at now is the axis of symmetry. Now, when we talk about the axis of symmetry, we're talking about that line that cuts the curve right down through the middle of the curve so that the left side of the curve can fold over on the right side. Now, when you think about for a perfectly symmetrical face, when a person have a perfect symmetrical face, you can draw a line from the forehead down to the nose, through the lip, so that the left side of the face would match on to the right side of the face. If you should fold that diagram right in the center there, right? So when that happens, that line that you draw down through the center is known as the line of symmetry. And in other words, in this case, we call it the axis of symmetry. All right, so here we have our parabola. Now, you notice that we have an x formula here, that x is equal to minus b over 2a. Now, this x value, so if you get your equation y equal to x squared plus bx plus c, you can calculate the x value through which that axis of symmetry will pass by simply taking the values of b from the